All right, guys, this is worksheet 16. We're going to talk about inverse trig functions today. Okay? You remember when we talked about a basic function. Oh, hang on, my cursor isn't working again. If we had y equals 2x plus 5 and we switched the x and the y and then we solved for, I'm trying to talk and think here. We did the inverse. Remember doing the inverse? And the whole idea with inverse was in order for a function to have an inverse that's also a function, it had to pass the horizontal line test as well as the vertical line test. Does that sound familiar? And that was the test for whether it was 1-to-1. Okay? So if we want a function to have an inverse that's a function, it has to be 1-to-1 and pass the horizontal line test. Clearly, sine, cosine, and tangent, because they're periodic and keep repeating, aren't going to pass the horizontal line test. Does that make sense? Okay. So in order for these to have an inverse, they have to have a restricted domain. Just want to go over this real quick. I don't know if you remember this, but when we did inverses, we talked very briefly about that. We talked about if there was a crazy graph like this and it wasn't 1-to-1. Next year in calculus, you might be told figure out a restriction, like from here to here or whatever this is, so that you're just talking about a piece that will be 1-to-1. Do you remember we kind of talked about a couple where you would restrict the domain and then it would be 1-to-1. That's what we're going to do today. We're going to restrict the domain on sine, cosine, and tangent so that each of them will be a 1-to-1 function, and then we're going to talk about their inverses. All right. In order to cover all the values of the sine function, we can't restrict it to this little piece, right? There won't be any negative values, and it's still not 1-to-1 if I restrict it like that. So what we're going to do is we're going to restrict it where these two dotted red lines are. We're going to restrict it from, where would this be? Negative pi over 2 to positive pi over 2. And then we're going to be talking about this little piece right here. Do you see that that would then be 1-to-1? Okay, it would pass the horizontal and vertical line test if we were only talking about that piece. Now, you remember an inverse means you flip all the x's and y's. That also then flips the domain and range. Sound okay? It also reflects something. Do you remember it reflects it across the line y equals x, so it looks like this? Okay. So this little guy is going to reflect and kind of go this way. Do you see how that is a reflection across the line y equals x? And it's going to look like this. All right. On your notes, I put this slide because I want you to think about the fact that we're going to restrict it from here to here, negative pi over 2 to pi over 2. Okay? And then over here, I want you to actually think about sketching the inverse. I'm not going to do this well. It would be smarter of me to just take a picture of the other slide, but I'll try. Okay. Again, this is going to be really bad. I'm just going to go with that. It is a piece of the sine function that has been reflected across the line y equals x, and it has endpoints because we've restricted the domain, okay? Now, on this graph, the x values went from negative pi over 2 to pi over 2. So on this graph, the y values go from negative pi over 2 to pi over 2 because this is the inverse. Everybody okay? We switched the x and y's. So what do the x values go from? Yes, because the y values over here were from negative 1-to-1, so the x values here are from negative 1-to-1. That's our inverse. And here's our restrictions, okay? What we're going to do with that information, though, is we're going to talk about finding, let me put an extra slide in here real quick. We're going to talk about finding the inverse sign. I'm going to write that. That's not what I want, but we're going to talk about finding either the arc sign or the inverse sign of a value. Now, we need to talk about the difference in these three. This and this have a single answer, okay? There's only one spot that any one value occurs on this picture. Is that true? Nothing repeats, right? None of the x's or y's repeat. So those have only one answer each. This equation, if I say 1/2 equals sine x, does everyone understand that there are infinite places that's true? The sine hits the value of 1/2. Think about your sine function going over and over and over. It hits at, so this has infinite answers. Let's see. Pi over 6, I think, is one. But then there's also one over at 5 pi over 6. You could answer in degrees. You could answer, 2 pi plus pi over 6. Everybody okay that there's... We're going to talk about these today. These have only one answer. What the question is asking when you see arc sine of 1/2 is it's asking where is the sine 1/2? But we're using this restricted graph, so it only occurs one place. Now, the answers for this kind of thing, like, let's think about, this is exactly the same notation, by the way, guys. Means exactly the same thing. I wish I could tell you, because I was really smart and knew the history of math, why there's two different ways to write it, but I don't know. This is the one that gets students. Can you find that on your unit circle? Where is the sign negative? Square root of 3 over 2. Remember, when you're looking on your unit circle, the first number is cosine, the second number is sine. You can use the one I gave you today, this little guy. Do you see somewhere where that's true? Okay. It happens at 4 pi over 3, yes? And it happens over at 300 degrees, which doesn't have a radians because I erased it. Everybody okay? The problem is, the reason I gave you this little unit circle is because our answer that we state has to fall between negative pi over 2 and pi over 2. What quadrants is that in? 1 and 4. So I can't use 4 pi over 3. It's in quadrant 3. But I also can't state that it occurs at, what would that be, 5 pi over 3? Okay? Because 5 pi over 3 doesn't fall between those numbers, even though it's in quadrant 4. Instead, we have to call it by its negative name. So, I took the unit circle for you, and I called it an inverse unit circle up here at the top of your paper. And we need to renumber these using negatives, and then we're going to use those answers when we answer that question. So 330 is actually negative pi over 6. 315 is negative what? Pi over 4. 300 is negative pi over 3. And this guy down here, negative 90, is negative pi over 2. Okay? Now, the trick is, when we get to cosine, it's going to be two different quadrants we look at. Yes. Okay, here. Anybody else not have one? Okay, I'm sorry. I don't know if you guys weren't here when I was passing them out, or I just totally missed you. There you go. Need a couple markers to color those in, okay? What we're going to do is we're going to remind ourselves to look in only those two quadrants, okay, when we're talking about the inverse sign. So here's my little color coding to remind myself only those two quadrants between negative pi over 2 and positive pi over 2 can I look for a sign, arc sign or inverse sign. Now, eventually you are not going to be able to use this colored unit circle. You're going to have to learn to use the regular unit circle that's on your gray sheet. It's not going to be renumbered. You're going to have to do that in your head. And it's not going to show you which quadrants. You're going to have it memorized. But for the next assessment we have, you will be able to use this one, okay? All right, quickly moving on to just a couple really quick examples. So look at that colored unit circle. Where did you find this value? That's what arc sine and inverse sine are asking. What is the angle where this occurs? Positive square root of 3 over 2 in the sine, guys. Pi over 3? Okay, go to this last one because the one in the middle is just funky. Where is the sine negative 1? Negative pi over 2. Everybody okay? All right, this one is totally weird. First of all, that looks like an angle to me, not a value. But the only thing arc sine can do is plug in a value and find the angle. So if we pretended that was a decimal in radians, or just a decimal value, okay, can the sine ever be negative 6 something? Picture the sine graph. It only goes between negative 1 and 1, right? So this is not possible. And they throw some of that on some of the homework. All right, I'm going to move on to cosine real quick. Cosine has to have a different restriction. If I restricted this from negative pi over 2 to pi over 2, it wouldn't work, right? I wouldn't have any negative values. Everybody see that? So, okay, gonna have to erase because I can't see my little undo button. We're gonna restrict it here from 0 to pi so that it has all the values. But it does mean when we reflect this, okay, when we reflect this, it's going to go this way. Do you kind of see how that's a reflection across this line? I did a crummy job as usual, but all right, so this is the graph that we need to sketch on our homework, and I am going to cheat. I don't know what just happened. Ooh. Okay, can you go to your homework here, or your notes, I'm sorry, and this is what you need to sketch next to that guy. You need to say this one was restricted this time from here to here. Oh my goodness, yep, pretend those are a nice rectangle, Hofbauer. Okay, this is the shape. It is over here the x values were 0 to pi. So over here the y values are 0 to pi. On the original function, the y values were negative 1 to 1. So now the x values are negative 1 to 1. In our book, one second, Jordan, just let me finish this sentence before I forget. In our book, it has students do a lot of graphs of the inverse functions and stretches them and shifts them and all that kind of stuff. I don't know a purpose for that, so I'm not going to have you worry about the graphing, just finding the inverse values. Does that seem okay? Jordan, what's your question? That's a good question. Let me... When I take this, okay, and I reflect it across this line, this value goes over here. This value that was at like positive something, negative something, goes at negative positive up here somewhere. Okay, so it's going... Do you see how those are reflections of each other across that line? This matches up here, this matches up over here. Do you see that a little bit? Okay, that's the definition. The other thing, Jordan, is that this is actually like 3, right? Pi is. So this is kind of a funky sketch as far as it's stretched further this way. This is a distance of 2. Where this is a distance of 3, so it is stretched a little funny. All right, guys, so what quadrants are we in if we're between 0 and pi? See on the screen there, what's red goes from 0 to pi. So on your unit circle, I'm actually going to go back to this slide real quick. I want you to add another color and say, I'm going to look from here to here for all my inverse cosine stuff. Oh my goodness, that's horrible coloring job. So the arc cosine is going to be green on my sample here, and it's going to go from 0 to pi. Do we need to renumber anything? Nope, 0 to pi, they're already numbered 0 to pi, right? Okay, because I'm trying to do this quickly, I'm going to talk about tangent, but while we're on this screen, tangent has the same 2 quadrants that sine does. So I only use 2 colors on mine. I just write my, oh, I meant to do blue, sorry. I write myself a note that arc tangent is also blue, and it's in those same 2 quadrants, okay? So whatever you did for sine, tangent is the same, and I'm going to talk about y in 1 second, but while we're on that slide, Faisal and Jacob and who's ever watching this video, I actually made the 2 of you each a unit circle that I'll send with your homebound instructors. All right, so before we do tangent, let's just do a couple quick examples, guys. Where is the cosine negative square root of 3 over 2? Remember, cosine is your x coordinate, so you're looking for this. Everybody okay? Where does that occur? At 5 pi over 6. Now, we couldn't answer that. It's not the right quadrant for arc sine or tangent, but it is for cosine. All right, does the cosine ever go up to 2.5? No, only goes 1 to negative 1, right? Where's the cosine negative 1/2? 2 pi over 3. Everybody good? All right, tangent, again, I'm going quickly, but tangent is this restriction because that seems really nice, right? It covers all the values. That's how I always draw it. I don't know about you. I put on negative pi over 2, draw, and then I start repeating. So the issue is when we turn it sideways, okay, we're rotating it. It will look like, whoa, I don't know what I did, sorry. How many times a day do I say that, guys? Yeah. I don't know, does this help, Jordan, just a tiny bit? It's actually, it's reflected, okay? Here's the original, no, I can't flip it. Oops. You get the idea. I wish I could flip it around, but it won't flip the way I want it to. It's not rotated, it's flipped. All right. Do you have that, whatever you want off that slide while I was putzing? Everybody got something sketched on their notes if they want. This one does have horizontal asymptotes here, but and actually the horizontal are at negative pi over 2 and pi over 2, and it goes on infinitely left to right for the domain. All right, so again the quadrants are the same, but we need to talk about the unit circle because tangent isn't on here. Really quickly, help me write down what the tangent of these are. Don't write this on your unit circle, please. You need to be able to do this without writing it down, but help me right now. Y over x would be 1 over 0 or, okay. At this spot, remember we spent a lot of time talking about what happens, the denominators cancel out. Everybody okay when you flip them over and everything? So this one, y over x, just becomes square root of 3 over 1 or, okay, what about here? That mess over that mess becomes 1. This one is 1 over square root of 3, which simplifies to, this one is 0 over 1, which is 0. This one is negative 1 over square root of 3, which is, guys, I just said you can't write this on your unit circle. You can write it on a paper somewhere, but when I go to let you use your unit circle, you can't have it written on there. This is negative 1 over square root of 3, so it'd be negative square root of 3 over 3. Everybody okay? This is this garbage over this garbage, which would reduce to negative 1. This is negative square root of 3 over 1. Down here would be negative 1 over 0 or undefined. Are we good? All right, so with that in mind, where did we just talk about the arctangent is negative square root of 3 over 3? That one's the hardest one of all for me. I have to kind of think about, that means when I put y over x, I had this, because then it rationalized to this. Now I need a negative, so I need that ordered pair. Where does that occur? Yes, everybody okay? Where's the arctangent negative 1? It's in quadrant 4, but remember the restricted values are negative pi over 2 to pi over 2, so it's at negative pi over 4. All right. So, did you already do these yesterday? Okay. Let's do a few more. Quickly going through these examples on worksheet 16, side B. Where is the tangent 0? Y over x is 0 at 0 radians. You don't have to write radians. It just helps me realize this was a value and this is an angle, okay? These are all in radians. Where's the sine square root of 3 over 2? Pi over 3. And we could write radians again if we wanted. Where is the cosine square root of 2 over 2? Cosine, positive square root of 2 over 2, pi over 4. Everybody okay? Where is the tangent negative 1? Now the tangent is negative 1 at 3 pi over 4. How do I know that's not the right answer? Yeah, it's out of the range. For tangent, remember we're using, that's why the coloring, okay? So you remember which quadrants you're doing. So this is negative pi over 4. All right, arc sine, where's the sine negative square root of 3 over 2? Anybody? Negative pi over 3. Where's the sine negative 1/2? Negative pi over 6. Now, I know yesterday this question threw you. Okay, by the way, this is screwed up. You don't have both an arc sine and a negative 1. Yeah, somebody's like, well, they undo each other. I don't know. That's just wrong. It's a typo. But this question says, what is the tangent at negative 3 pi over 2? That's a question from 2 weeks ago, just mixed in here. What's negative 3 pi over 2? It's the same as positive pi over 2. So what's the tangent at 90 degrees, basically? Tangent is y over x, so it's, this was not an arc tangent question or arc sine or arc cosine anything. We just did this one. This is the tricky one, remember? We're looking for that one. Negative pi over 6. Where's the cosine negative 1/2? Careful, cosine are negative over where? Quadrant 2. Everybody okay? I'm not, obviously. Choking here. Where's the sine negative 2? Not possible. Everybody okay with that? Only goes from negative 1 to 1. All right. Remember doing composition of functions where we had some crazy business like this and you had to put the answer for f into g? Okay. I don't know if you also remember we had things like this is one function and this is another function, and if you put f into g it should cancel out and get back to x if they're inverses of each other. Kind of remember that? Inverses undo each other. Okay, so we'd have like square root of, cubed root of x and x cubed, and if we put one into the other, they canceled each other out. That's the idea here. Inverse functions will cancel each other out if there's an appropriate domain. Now, I gotta tell you, I assume every time that it's not going to cancel it out, and I do the problem because it really makes me nervous. Let me show you what I'm talking about, okay? If I had this question, number 11, this arc sine and sine may cancel each other out, and the answer may be -3/4. But I'm not positive until I'm sure I'm in the right quadrant. Now, the arc sine is negative in what quadrant? This is not on our unit circle, right? So this one throws everybody off. But it's in quadrant 4. If I had an angle down in that quadrant whose sine was opposite over hypotenuse, everybody with me? This would be negative, right? Because it went down. Now this question says, whatever that angle is, what is the sine there? So I don't know what the angle is, but I do know that its sine value is just -3/4. Okay, that one canceled each other out. We're good. We find the angle whose sine is this, and then we find its sine. So it just undid each other. Let me give you an example where it doesn't, okay? I would look at that question and go, the answer is 11 pi over 6 because they cancel each other out. But it's not, because the arc cosine is not defined at 11 pi over 6. So you have to work your way inside out. Remember, that's why I did an example where we talked about you put g into f. Okay, find this answer. What is the cosine at 11 pi over 6? Look at your unit circle, or your regular unit circle, whatever. 11 pi over 6 has a cosine of square root of 3 over 2. And then it says, what is the arc cosine of square root of 3 over 2? Well, the arc cosine is only defined in quadrants 1 and 2, so the answer has to be, right, square root of 3 over 2, positive, and the x for cosine happens at pi over 6. Everybody okay? So that's one where if you just assumed these are going to cancel each other out, you'd get it wrong. All right, let's try some more. Take your unit circle. What is the cosine at pi over 2? Help me out. Nope. Cosine. Cosine at pi over 2 is 0. Now it says, where is the inverse cosine, or where is the cosine of 0 occur? At pi over 2, right? That one just canceled each other out. It just became, the inverses took care of each other. All right, the tangent at 3 pi over 2. Tangent at 270 degrees. Anybody? -1 over 0, which is undefined. The arc tangent of undefined, you can't answer that question, okay? You just have to say that you can't do that question. I don't like that, but that's the case here. All right, this one clearly is not going to cancel each other out because it's an arc sine and a cosine, right? All right, cosine of pi over 6. You look quickly and you say square root of 3 over 2. Everybody okay? And it wants to know, where does that sine value occur, and it wants an angle. So that sine value occurs in the y coordinate spot at pi over 3. Everybody good? If you're not looking at your unit circle and you're just writing down notes, this is making no sense whatsoever. I'm just speaking Greek. Is everybody looking at the unit circle? Okay. Number 15. Where is the sine 1/2? I want an angle. Pi over 6. Now it says, what is the cosine at pi over 6? Square root of 3 over 2. We're good? Okay. Where is the sine -1/2? So I'm undoing a sine of -1/2, and I get an angle of -pi over 6, right? Because the sine is negative down in quadrant 4. What is the tangent at that same spot? -1 over square root of 3, which is negative square root of 3 over 3. Yep, some of you have gotten that down very quickly. All right, is the cosine ever 2? Kind of gave that one away, but yeah, this one does not exist. Okay. We just did this one, otherwise it would be a little bit trickier to think about, but where's the tangent? Negative square root of 3 over 3. Negative pi over 6. And what is the cosine at that spot? Now, arc cosine isn't defined down there, but cosine is defined everywhere. So cosine is... All right. Can I skip just a couple? I'm going to skip this one. You guys have this. This one says 5 pi over 3 on yours, right? Okay, what is the cosine at 5 pi over 3? Which we just covered up on our unit circle. It's 300 degrees. The cosine is 1/2. And what is the arc cosine of 1/2? In other words, where is the cosine positive 1/2? Pi over 3. Your paper says, what is the cosine at 5 pi over 3? 5 pi over 3 used to be on your unit circle. I scribbled it out, erased it, and it's 300 degrees. Okay? You would be able to use a regular unit circle at the same time, okay, which would have those on it. All right, guys, 21 looks horribly difficult. You're going to seem so smart when you get this answer, okay? It's not that hard. What is the sine, arc sine of positive 1, pi over 2? Where is the cosine 1/2? It is, okay? This is 3/6 minus 2/6. If you get a common denominator, is 1/6, right? So we simplified in the parenthesis down to 1/6. So what's left to do is to find the tangent of that. And the tangent at pi over 6, anybody? Pi over 6 tangent. Square root of 3 over 3, right? Okay, I thought I heard just square root of 3. My bad. All right. And arc tangent of negative square root of 3. Be careful. Got to kind of test them until you find that one. Where's that one at? Good job. And what is the sine down there, the plain old sine? Sine is the y value. Feeling confident that this is pretty easy? Excellent. Okay. This is the book assignment. I'm going to stop this recording. Good luck. Oh, I pushed the wrong